Hello friends, myself Rajendra Mahajan presenting my video on Cayley Hamilton theorem. Its use to find inverse. Let us solve the problem. Obtain A inverse by using Cayley Hamilton theorem, where matrix A is with the element 1, 1, 0, 0, 0, 1, 2, 1, minus 2. Therefore, to find this inverse, the first of all we have to obtain the characteristic equation. Characteristic equation is given by determinant of A minus lambda I is equals to 0, where lambda is any scalar quantity and I is the identity matrix of the same order. Here the order of that matrix is 3 by 3. Therefore, I must be of order 3. That is, by shortcut method, it is nothing but lambda cube minus s1 lambda square plus s2 lambda minus determinant of A is equals to 0. We call this equation 1, where the value of s1 is the sum of the principal diagonal element. Therefore, that sum is 1 plus 0 minus 2, and therefore 1 minus 2 we get that value as minus 1. S2 is this sum of the minors of the principal diagonal element. Therefore, we first find the minor of the first diagonal element, neglecting first one first column and taking a determinant of the remaining elements. Remaining elements are 0, 1, 1, minus 2. Then minor for second diagonal element, neglect second row, second column, determinant of 1, 0 and 2 minus 2. Then minor of the third diagonal element, minus 2, neglecting that third row and third column, and determinant of 1, 1, 0, 0. Finding the value. This one is 0, minus 1, minus 2, minus 0, and 0 minus 0. We get that value as minus 1 and minus 2, and therefore that value is minus 3. Then we have to obtain the value of determinant of A. It is determinant of the elements of that matrices 1, 1, 0, 0, 0, 1 and 2, 1, minus 2, 2, 1, minus 2. Evaluating this third order determinant as usual, therefore 1 into product of this as 0 minus this product 1, second term with minus sign, neglecting first row and second column, determinant of 0, 1, 2, minus 2. Therefore, product is 0, minus 2 and 0. 0 into in number we get 0. And therefore, simplifying it, we get this value as minus 1 and plus 2. Value is plus 1. Substituting in equation 1, we get lambda cube minus s1 lambda square. S1 is minus 1, minus and that minus it become plus lambda square, plus s2 lambda, value of s2 is minus 3, and minus plus minus plus and then minus. Therefore, minus 1 is equals to 0, equation number 2. This is the characteristic equation of that matrix A. Then we have to apply Cayley Hamilton theorem. Characteristic equation is satisfied by that matrix A. Replacing lambda by A, we get A cube plus A square minus 3A and minus 1. we convert it in terms of matrix form by multiplying it by identity matrix, and therefore we get 1 into I as I, means minus I, and equals to 0. We call this equation 3. In the previous video, I have discussed the first type, where to verify Cayley Hamilton theorem. That is the one type of question that can be asked on Cayley Hamilton theorem. Here we are not interested to verify that Cayley Hamilton theorem. Instead of that, we have to obtain A inverse by Cayley Hamilton theorem. And therefore, the procedure is that we have to pre-multiply this equation 3 by A inverse. Pre-multiplying by A inverse. Pre means on the left hand side of that matrix. And therefore, we take A inverse multiplied by that equation. It is A cube plus A square minus 3A minus I equals to A inverse into 0. We get 0 on the right hand side. Multiplying it inside, we get the new terms as A cube into A inverse, or A inverse into A cube as A square, adding the powers. Then A inverse into A square, we get A inverse into A, we get as identity matrix, and minus any number by identity number, we get the same number. Here same matrix, and that matrix is A inverse and is equals to 0. And then solving it for A inverse, and therefore we get A inverse as, transferring this term to right hand side, we get A inverse as A square plus A minus 3I. We call this equation number 4th. And to obtain this, we have to obtain matrix of A square and then addition of all these 3 matrices. Therefore, next step, we try to obtain the value of, matrix of A square. A square means matrix A into matrix A. Matrix A is 1, 1, 0, 0, 0, 1, 2, 1, minus 2. And same is multiplied by same matrix 1, 1, 0, 0, 0, 1, 2, 1, minus 2. And as I have explained in the previous video also, here matrix multiplication is possible. Then we multiply by row to that column. One into 1 we get 1. 1 into 0, 0. And 0 into 2 we get 0. Next, by first row to that second column, we get 1 into 1, 1. 1 into 0, 0. And 0 into 1 we get 0. Next, by first row to the third column, 1 into 0, 0. 1 into 1, 1. And 0 into minus 2 we get 0. Next, by second row to that column, 0 into 1, 0. Again 0. And then 2. Next, by second row to second column, we get 0. Next 0. And next 1. Next, by second row to third column, we get 0, 0, and minus 2. Then third row to that first column, 2 into 1 we get 2, 1 into 0, 0, minus 2 into 2 we get minus 4. Next, second row to second column, 2 into 1, 2, then 0, then minus 2. Third row to third column, elements are 0, then 1 and plus 4. 1 plus 0 we get 1. Then again 1 and third element is also 1. Then second row, first element is 2, middle element is 1 and last element is minus 2. The four elements are 2, 1, minus 2. Then 2 minus 4 we get minus 2. 2 minus 2 as 0 and 1 plus 4 as 5. This is the matrix of A square. Then substitute this in equation 3 along with that matrix A and identity matrix. Therefore we get A inverse as A square. Matrix of A square is 1, 1, 1, 2, 1, minus 2, 0 and 5. Then plus A matrix A is 1, 1, 0, 0, 0, 1, and third row 2, 1, minus 2, 2, 1, minus 2, and 3 minus 3i. I means identity matrix of order 3, and therefore it is 1, 0, 0, 0, 1, 0 and 0, 0, 1. And then adding the elements. 1 plus 1, 2 and minus 3. 2 minus 3 we get as minus 1. Then 1 plus 1, 2. 2 minus 0 is, we get second element as 2. Next 1 plus 0 and minus 0. 1 plus 0 we get 1. Therefore first row minus 1, 2, 1. Then 2, 0. 2 plus 0, 2 and minus 0 means it is 2. Then 1 plus 0, 1 and minus 3. 1 minus 3 we get minus 2. Then minus 2 plus 1, minus 1 and plus 0. Therefore minus 1. Next minus 2 plus 2, 0 and minus 0. We get 0. Next 0 plus 1, 1 and minus 0. We get 1. Next 5 minus 2. 5 minus 2 we get 3 and minus 3. 3 minus 3 we get 0. Therefore A inverse is minus 1, 2, 1, 2 minus 2 minus 1, 0, 1, 0. This is the required answer or required matrix of A inverse. Whether it is correct or wrong, that we simply check by performing this, and do it yourself. I will not perform this calculation. Cross check. What is the property? Property is that product of A into A inverse is identity matrix. Means if we multiply this A inverse by that matrix A, and if we get identity matrix, then whatever the matrix obtained is the correct one. And if you are not able to get the identity matrix, means answer is the wrong one. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.